and then, just as before, push this entry into my log, and then add another else if block where I check if the event is equal to, let's say, log event monster attack, in which case we can also copy that code here. And here the target would be player, that's the difference. Now let's add another case, because we also might have the event that we healed the player. So log event player heal here. And therefore, again, we can copy in that code. The target here is the player, of course. And then we have the last else if block here. The event is that we have the game over case. And there we have no target, so I don't need to set a target here. Instead, I just have my log entry like this, where I output with the final healths. Value then in this case could be the name of the winner, so player or monster, or draw if we have a draw. And, well, then we push this onto our log. Now I push to the log in every case, and therefore we can actually remove that line from the if cases here. So for all the else if blocks and for the main if block, I remove this. And instead, I can push log entry onto the battle log after the entire if block, because we know we have a log entry variable. It will hold some value after all these if checks, unless we passed in an EV identifier, which is not covered here. And then we push that entry onto the log. And that uncovered event identifier case shouldn't really happen here, because we will call that function, and we as a developer here will make sure we don't call that function with an invalid value. Alternatively, of course, you could add an extra check, and before you execute any code, check if EV is log event player attack or strong attack or monster attack and so on. And if that is not the case, so actually check if it's not that or not that or not that and so on, then you could return basically such a check, as we also added it earlier in this module in the calculator already. Here I'll not do it, but it is something you could do. Now with that, we create these different log entries here, and you could even refine this code a bit more and actually set log entry to an object here, where you do have all these fields which are always the same. Whoops, didn't want to cut them there. So everything except for target. And then here you would only add log entry dot target and set this equal to monster here, for example. So only add a new property dynamically, which you can do in JavaScript with the dot notation. If you access a property which doesn't exist yet, this will add it dynamically. So you could do that and save even more code. I will leave these other log entries here like this though, just to make it really clear that we do set this information on every if block. We do it with this other approach too, but this might be easier to read and to understand. This approach, however, where you only change the target, of course, is the more dynamic or the shorter approach, and therefore the approach you might want to use in bigger apps. Side note, if you do follow that approach where you set up that object up there and thereafter you only change the target, you can of course omit that last else if block here, because there we don't set a target, so there we already got the readily configured log entry with our default log entry up there. So that's just a side note. Creating all these extra objects is a bit redundant, but I leave it like this for readability here. Then we push that onto our log, and with that we should have a log. Now let's make sure we can also output it. And for that, in the vendor.js file, we have the log button to which we can add an event listener. So I'll do that in app.js at the very bottom here. I add my event listener for a click event, and there I want to have my let's say print log handler function, which doesn't exist yet, which we have to create, maybe right down there, the print log handler function. And in that function, I want to output the log, and for now I'll just console log the battle log, the variable, which should be that array. Now we just need to make sure that we actually call write to log for every event that we do want to log, because right now that's not something we're doing. So let's do it. And for that, of course, in end round, when the monster hit us, I want to call write to log with my log event monster attack identifier, because the monster attacked us. The value then is player damage. And the monster health at this point then is the current monster health, and the player health is current player health. So this is how we can call this function here. We can also restructure this across multiple lines with the auto formatting shortcut to make that a bit easier to read. So that's right to log after the monster hit us. Now I also want to log when the game is over, and that of course is the case whenever we also call reset. But I need to know whether we won or lost or had a draw, so I will actually write to the log here in these checks where I do know whether we won or the monster won. And then here I will create my log event game over. The value which I now pass in is not the damage, but instead the result of the game. So here that could be player 1, whatever you want to use here. That's any text you want to put into your log message, into your log object. The health snapshots, and then do the same here for the monster if it won, so monster won, and also down there if we have a draw, then maybe output a text of a draw. In the end, you can put any data you want in there. And now we got 2 other events which I want to log, or 3 other events actually. That's when we attack the monster, strong or with a weak attack, and also when we heal ourselves. So let's start with attacking the monster. So here I also want to write to the log after we reduce the monster's health. And which event I write to the log differs based on the mode we have here. So actually we can add a new variable, log event, and then log event is either equal to log event player attack here, or if we selected a strong attack, it's log event strong attack. And now log event is a variable that holds either of the 2 identifiers, so the string values stored in these constants in the end. And therefore now here, when I write to the log, I can use log event, this variable, which is one of my identifiers, or to be precise, the values stored in these identifiers, of course. The value which I want to write to the log is the damage that was actually dealt. And then again, I take my current monster and player health snapshot. And now there's one last thing I want to write to the log, and that is when we healed ourselves. There, after we adjusted the player health, I have my log player heal event. Then I healed by the heal value here, heal value like this, because that's the actual heal value by which we healed. And then again, my health snapshots. So now with that, we should have all that functionality implemented. Back in the app, we can open the developer tools now to see the console. And if we now reload and start a new game and we attack and a strong attack and we heal, and then I show the log, we have 6 events in there, and that makes sense. We have a player attack where we hit the monster for a value of around 6, and that makes sense because the monster health thereafter is around 94. Then the monster attacks us for around 4 damage points, which again makes sense. Monster health is still what it had after we hit it, but now the player health is reduced by that damage here. And then we launch a strong attack with a value of 10. Monster health thereafter is 83, which makes sense. It was 93 something before, now it's 83 something. After hitting it for 10 something, player health is unchanged. Monster attacks us, so now, well, this is the damage it dealt to us. This is our health thereafter. And so on. We healed ourselves. There you see we healed ourselves for around 6, fully up to 100 thereafter, but then the monster hits us again, takes us down to 90, and that's basically what we see there. Now let's continue here and launch a couple of strong attacks until we win. Yep, we did. And now print the log. Lots of messages in there. In the end, you see the game over message. And there you see player 1 and the final monster health below 0, of course, player health above 0, and therefore this all works. This is how we can write to the log and how we can output the log like this. Now later we will learn about loops and therefore how we can output this log in a bit of a nicer way instead of just throwing the entire array in there like this. But for now this will do. And with that we also had a lot of if usage. Now I want to dive into some of the neat features which we haven't really talked about yet when it comes to if statements, about conditional code, before we thereafter dive into loops. There is one special conditional expression which we haven't seen and used thus far, and that's the so-called ternary operator, or the ternary expression. It's important to understand that if statements themselves return no values, right? You just dump them into your code to then execute code conditionally. It's not like a function or a calculation with some operators. If statement doesn't return any value which you could store somewhere. Therefore, this, for example, does not work. You can't assign a if statement to a constant, because this will not return anything. An if statement won't return anything, and this will actually be a syntax error, therefore. This is not allowed. But maybe you have code where you want to use a different value in, let's say, username or any other constant or variable, and the concrete value you do want to save in that constant depends on some condition. Actually, that is something which we have in our code already. Here in attack monster, we have max damage and log event, and these are variables that hold conditional values. They either hold, for max damage, attack value or strong attack value based on this condition, and thereafter we use that variable. So in the end here, we have a variable where we store data that depends on some condition. But I do so by first setting up the variable and not assigning any value. And then we have a if condition, which we don't try to store in any variable or constant, because that wouldn't work, as I mentioned. And then inside of the if condition, we assign values to max damage in this case, and to log event as well. This is valid code and this works. But this snippet here doesn't work. But it would be convenient to have some kind of if statement that would work like this, where we kind of return a value in it, and then that returned value gets stored in a variable. Would save us some extra lines of code. Well, there is a solution for that. You can use the so-called ternary operator in such cases. It allows you to have an inline if statement, if you will, without the if keyword, because that can't be used inline, but with the question mark and colon operators here. And together they make up that ternary operator. Now, the logic here is simple. You first put your condition which you want to check, and there you can have any condition you could have in an if statement, including multiple conditions combined with and or. Then you have the question mark, and thereafter you have the value you want to use if the condition is true. And that's important. You have a value here, so something which could be stored in a constant. You don't put more complex code here, not multi-line code, not multiple expressions. You can't use an if statement here or define a new variable here. Instead, here after the question mark, you need some value that could be stored in a constant or a variable in any other place as well. So which you could directly assign with the equal sign to a variable or constant. And then you have a colon, and then you have your else value, and you need to specify this. So omitting that else value is not allowed. That would be a syntax error as well. So here we have the islog in condition, which probably is a boolean or some truthy or falsy value. And if that is true, we store max in username. If it's not true, I store null in username. This is a ternary operator in action. And we can actually use that in our code as well. We can change that code to not use this if statement. And let me make it very clear that there is nothing wrong with using an if statement like this. In some cases, using explicit if statements like this might also lead to more readable code than using ternary operators. But in some cases, you also can save some extra code by using ternary operators. And for example, here we can comment out the if statement and set max damage here equal to, and now I check if mode is equal to mode attack. And then if that's true, separated by a question mark, I assign the value to max damage that should be used if mode is equal to mode attack. So basically attack value here. And otherwise, separated by a colon, I use the else case. So in this case, strong attack value. And now we set that variable to either attack value or to strong attack value based on this condition. So on this condition, if mode is equal to mode attack. Now, of course, since I therefore never reassign a value here, previously we did do it because we assigned values in the if statement. Now we initialize this variable with a value right away, thanks to this ternary expression. We can also switch this to be a constant because I never assign a new value. We never use the equal sign after max damage again in this function here. And of course, we can do the same for the log event. We can also switch this to a constant and now assign a value based on this check here. So check whether mode is equal to mode attack. And if that is the case, then we have a value of log event player attack. Otherwise, we have a value of log event strong attack here. And we can also structure this across multiple lines like this. I did this with the auto formatting shortcut. As you see, it's no problem. As always in JavaScript, you can write your code along multiple lines here. JavaScript then finds out where this ends with the help of the semicolon here. So with that, we removed that if statement and we saved some extra code here. We are able to initialize these constants right away, and therefore we are able to use constants instead of variables. And as I mentioned, this is now not strictly better than using the if statement. Absolutely do use the if statement, especially if you had more complex conditions here and more complex values where you maybe also run some calculation first of all. So where you then all of a sudden have very long lines of code, then you might actually prefer having an if statement where this is more structured and readable. If you have relatively short conditions and value assignments as we have it here, however, then using the ternary expression is a fine alternative that can save you some extra code. Well, and with that, we should see that if I reload here and I start my game, that still works as before, but now with the help of the ternary expression. It's also worth noting that a ternary expression can also have nested conditions. So here where a value is expected, you can have some other check and then have a nested ternary expression where you then have the nested value and the nested alternative value here, but you should use that with caution because that can quickly lead to very hard to read code, and using a real if statement with else if blocks often is the better alternative to deeply nested ternary expressions. Nonetheless, it does work, it is supported, and it is something you can use, especially if you have short code, short conditions, and it's not getting unreadable. It's time for a little bit of behind the scenes theory about JavaScript code and how we call things there. You might have heard me say things like statement or expression. Well, there actually is a difference. This here is an expression. Basically, in JavaScript, an expression is something that yields a value you could store in a constant or a variable or return in a function, something like this. That's an expression. Now, every expression also is a statement. This here, for example, is also a statement. But if statement, on the other hand, is just a statement, not an expression, because you can't use it in the places where you, for example, just need a value, as you just learned. You can't do that. Instead, a if statement here can only be used in code like this. You can't use it on the right side of an equal sign, basically. And therefore, this is a statement, but not an expression. So you could kind of memorize that an expression is basically something which would work if you use it on the right side of an equal sign. It's not super important for you to learn it by heart. I just want to clarify what I mean when I say expression or statement. And as you see, most things in JavaScript are expressions, but something like the if statement would be a statement. We will also see other statements later when we dive into loops, because these also are statements then. But for now, the if statement is the important statement, which is not an expression, which we learned about thus far. Now that we learned about ternary expressions, I also want to show you some other specialties you have in JavaScript when it comes to expressions and to conditional code and logical operators. And I can best show you this in the console because in our little project here, we have no real use case for the things I'm about to show you. I want to show you some nice tricks or shortcuts with logical operators. One important trick is how you can convert or coerce a truthy or falsy value to a real boolean. You do this with the double exclamation mark, also called double bang operator. Now we learned about the exclamation mark operator, which is there to negate some condition or a value. And by using two exclamation marks, you basically negate the negation, which kind of reverses the negation. But there is one important thing. The exclamation mark, so the single exclamation mark already, converts a truthy value into a real false value. And if you then convert that false value back with another exclamation mark, you could get a real true value, so a real boolean. So for example, if you use double exclamation marks in front of an empty string, you will get a real false boolean instead of that falsy interpretation which JavaScript normally uses. If you use double exclamation marks in front of a 1, you get a real true value. Now often it might not matter to you, but whenever you have code where you want to work with real booleans instead of let JavaScript do this truthy falsy comparison or coercion, then you can use the double exclamation mark to get such a value. So it's basically a type conversion trick which can convert an empty string to false or any number to true, things like that. And sometimes in code, in more advanced programs, typically you might need that, and then this is a convenient and handy approach. Another nice trick, if you want to call it, is related to how JavaScript works with the OR operator. You can use it to assign a default value to a constant or variable. So you learned about that OR operator, of course, and as I just said, you can use it to assign a default value with this syntax here. Now what does this do? This will check some input. And now imagine that some input is another variable or constant that holds some user input and that might be empty. Now remember that empty is a falsy value. An empty string is a falsy value, is treated as false. And the way JavaScript works with the OR operator is such that it has a look at the thing in front of the OR operator, so at some input, and if that is false, it will also have a look at the value after the OR operator, because it will return true overall if at least one of the two things in front or after it is true. And of course, the thing after the OR operator here would be true, right? Max is a string which is truthy. It's not an empty string, therefore it's truthy. So this will basically yield true overall. But now that's the important thing. Unlike our logical operators like the triple equal sign or the greater or smaller operator, the OR and the AND operator don't generate a boolean. You can use them to combine conditions and then they will return true or false, but not because they create true or false, but because they return the results generated by the conditions they are combining. Now, if you're working with two strings like you're doing it here with some input and max, and I'm assuming that some input also holds a string, what happens here actually is that OR will return the first truthy value without converting it to a real boolean. So it will keep the original value and return that. And in our other comparisons, like this here, for example, well, that generates a real boolean, that generates a real boolean. That's why OR returns a real boolean, because the things to the left and right of it generated real booleans, not because OR generated a real boolean. This only just returns the first truthy or true value it's looking at. And it starts from left to right, so if this returns true, it will return this true value and not even look at the second one. If this returns false or is a false value, it will look at the second condition, and if that then returns true or is a truthy value, it will return that value, either a boolean, as it would be the case here, because this operator generates a boolean, or, as in the case of this slide here, max, if some input is falsy, because max will be truthy and it will therefore return max. The AND operator allows us to do something similar. Instead of using it to assign a default value, we can use the AND operator to get the last value in a combined check like here. let's assume that is logged in here is a truthy value or a real true boolean, doesn't matter, but that it is true. In that case, AND will return the last value it's looking at, because AND, unlike OR, always looks at all, so at both values in front of it and after it, because all need to be true or truthy. And if both are true or truthy, it will return the last value. If the first value is true, it always returns the second value, or the value after the AND operator, I should say. If the first value is false, it will always return the first value. So here, we would return max if is logged in is true, and null or false or whichever value is stored in is logged in otherwise. Now, as I said, let's have a look at that in the console. Let's start with the double exclamation mark operator. Let's say we have some user input here, and that's an empty string. We got that from some input field, but the user pressed the OK button without entering anything. That's a use case you can have in web applications. You will actually have that a lot, that users enter incorrect information. Now, let's say we want to use that somewhere in our code, and in the end, in multiple places of the code maybe, I just want to know, did the user enter something valid or not? So of course, we could always check for user input, and this will be false because it's an empty string, so we could do something in the else block here. But maybe we want to use that is valid or not information in multiple places, so I create a new variable, is valid input, and that should be true or false based on user input. Then, of course, we could write user input and use this as a condition in a ternary expression, and after the question mark, we could therefore say true, because if user input is truthy, then we want to store true in is valid input, otherwise we want to store false. We could do that, but the shorter way is to just use the double bang operator here and say this, because as you learned, this translates it to a real boolean. So in this case, since it's an empty string and therefore falsy, this converts it to a real false value, to a real false boolean, as you see here. A single exclamation mark would also convert it to a boolean, but of course to the opposite boolean, because a single exclamation mark negates the value. So if it's falsy, it's turned to true. If it's truthy, it's turned to false. So if we want to keep the original meaning, so a truthy value should become true and a falsy value should become false, we need two exclamation marks to not negate it, but to instead just use this as a shortcut to convert the type. Let's now have a look at default values. Let's say we want to create a username here, and that's based on some user input, which of course is an empty string. We just set this up before, and if you clear here, the old values are kept, you just don't see them here anymore, but user input still is set, as you see if you want to output it like this. So now we want to create a username here based on user input, and now we either want to use the user input, but if that is falsy, so if it's empty, I want to use a default value of max, and we can do that with the double pipe symbol, so with the OR operator here, because now, as you will see, we'll have max stored in there, because user input is falsy. Of course, this would also work if it was a real boolean that's false, and therefore this is used. If it would be truthy, so if we have, let's say, the real user input, and that is manu, and then we set real user name equal to real user input or max, then real username will actually have manu stored in it, because that is a truthy value, and therefore in this check OR returns that first true or truthy value, which is the real user input, and does not use this as a default value. So this is how you can use the OR operator to assign default values to variables. Now, of course, you can also have more than one OR operator here. If you had multiple variables that might or might not hold a true value, you can have value 1 or value 2, or, and then at some point, some hard-coded default value, which you define probably. Now let's have a look at the double AND operator. For that, let's say we have a is logged in variable, which is true. And based on that, we want to store some other value. Let's say we have the shopping cart, and that's some data which we loaded from a server. And if is logged in, then we want to initialize this to be an array which already has some some books in it, something like that. If we run this, you see now shopping cart indeed is that array with the books in it, because is logged in is true. And as I said, if that's the case, then the double ampersand, so the AND operator, will have a look at this, then have a look at the second value, and if both are true, it will return the second one. And an array, no matter if it's empty or not, always is treated as a true value, which is why it returns that. On the other hand, if we set is logged in to false, you will see that now if you set is logged in and books, and of course we could store this in a variable or just output it like this to see what would be stored in a variable, you see that this now returns this false value that's stored in is logged in. Or if you had something here which is null, it would return null. So it basically returns the first value here. So here, for example, it would return null if we have that. So it returns the first value if that is false, the second value if both are true. Now what if the first is true and the second is false? Let's have a look at that as well. So here I set is logged in back to true, let's say. And then we check if is logged in and then something which is false, an empty string maybe, then it also returns this. So if the first value is true, it always returns the second value. If the first value is false, it always returns the first value. Now these shortcuts, these tricks might be a bit confusing, also because we have no real use case for them in this project. We will see them in some places throughout the course though, and you will also see them in projects you work on. Now be aware that these are always just shortcuts. What we do with them can always also achieved with the help of full if statements or with ternary expressions, but sometimes it's just shorter to use these shortcuts. That's the main idea. So if you forget to use them in a case where you could have used them, that's not bad. You will not have an application that's way slower or worse or anything like that. These are just alternatives which can save you some code, and you can always refactor your code to use them if you find a place where you can use them. But it's absolutely normal that you also sometimes overlook scenarios where you could have used one of these shortcuts. I just want to make you aware of them right now, so that if we do later use them in the course, you are aware of them, and also that you recognize these patterns if you see them in other code or in other examples. Now last but not least, to conclude that if statement part, I want to introduce the switch case statement, which is a new statement but kind of related to if statements. It's great in situations like this, where you have multiple equality checks, because that's where it really shines and where it is the most helpful, where you want to execute different code based on the condition that was met. Now you can also use switch case statements with other conditions where you don't check for equality, but there you save less code and they often are harder to read. So you typically use switch case statements, or you can use them as a replacement for if-else if statements with a lot of else if cases if you always check for equality and you're just checking multiple different values. So let me show you how you could translate this long block of if and else if blocks into a switch case statement. For that, you use the switch keyword, which is built into JavaScript, and the switch keyword doesn't take a condition, but it takes a value, a single value. So in this case, the event. Then you add curly braces and no semicolon after them. And then you can add the case keyword to define a case. The case now is a concrete value that could be stored in this variable or constant, or in this case parameter. So for example here, log event player attack. Of course, you don't have to use a constant here which holds the value. You could hard code it in here. Doesn't have to be a string either. You could be looking for a number, but by default, this looks for equality here. Now, if you're interested in some ideas of how you could use a switch case statement with greater than and so on, you will find resources attached to this video. But this is the most straightforward way of using it, the easiest to read way, the way for which it was invented, I would say, and the way where I would use it. If you have other conditions that include more complex conditions, greater than and so on, or combined conditions, I would always go for an if statement. If you have an if statement like this though, where you always have only one condition and you check for equality, then a switch case statement might be an idea. So how do you use it? You see I added a colon after this case definition, and then typically in a new line, you define which code should be executed if this case is met, so if EV has a value of log event player attack. Also worth pointing out that behind the scenes, Switch always uses the triple equal sign operator to compare that. So it only will go into that case if the event holds log event player attack, both regarding the value but also the type. So if event really is a string in this case, because that's what's stored in log event player attack. So now we have that case defined. Now we define the code that should be executed if that is the case. So in this case, I want to adjust my log entry target. And then you can define a second case. In this case, a case here that the value stored in EV is log event player strong attack. And then again, colon, and then the code that should execute. So either you again just manipulate the target, or as I do it down there, you create a brand new object which you store in log entry. Now, very important, you also should add another special keyword after each case, and that's the break keyword followed by a semicolon. Now, we haven't seen the break keyword before. It's a keyword built into JavaScript. And in the end, what it tells JavaScript is that if that case has been handled, no other case should be handled. Because by default, Switch case statements do something which is called fall through, which means if you made it into that case, then that case would be executed as well. Because the default behavior is actually that if it made it into a case, it will also execute the cases below it automatically, even if these don't match the value. Sometimes this is exactly what you want. Sometimes you want to have the same code for multiple cases, and you could achieve that by not defining any code for a case. Then, thanks to the fall through mechanism, if this case is met, it goes right to the next case and executes this code. But in other cases, you only really want to execute one piece of code for each case, and then you add the break keyword to tell JavaScript, after this is finished, don't evaluate any other cases, just leave the switch case statement, we are done. So now let's also add break here, and then, again, add another case, and that would be the log event monster attack. So let's add this here, and thereafter that code which we had in this else if block. And then add yet another case here. Now here for the player heal. So let's add that here. Also don't forget the break statement here. I did forget it, so make sure you don't. So log event player heal. There, of course, I'll grab this code, which I have down there in the else if block, add it here below case, and add the break keyword. And then add the last case, and that's our event game over. So let's add that here, whoops, like this. Also, of course, copy the code we have down there, add it here, and maybe also add break here. Of course, here, though, you could omit it because we have no other case below it. Now, in switch case statements, you also have another special keyword, and that's default, followed by a colon. That allows you to define some default code in case no case is met, and therefore you make it into no entry point here. Then you would add default to still execute some code maybe in case no other case is met. So here we could set a log entry to an empty object, for example. Now, of course, that means that now I can comment out the if-else if statement here and just keep my battle log push code line. And with that, we have a valid switch case statement. Now, is that better than if and else if? Well, if you have such strict equality comparisons, it can be a bit cleaner to read, and therefore it's a real alternative, which I tend to prefer. But ultimately, you can also stick to if, else if you prefer that, if you find that easier to read. And especially if you have more complex conditions, multiple combined conditions, or greater than checks and so on, you definitely want to use if, else blocks and statements instead of the switch case statement, because that really only shines for strict equality checks. After all these if statements, which are extremely important, which is why I spend so much time on them, because you will basically need them in any program you write. So after the if statements, it's now time to come to another very important construct in JavaScript and in actually any programming language, and that would be loops. In programming, you often have the scenario that you need to execute certain code multiple times. Now, you might think, okay, we have functions for that. We can have reusable code in there. We can call a function multiple times. Sure, but in your code, you have to write every function execution, right? Of course, you can attach a function to an event listener, and then whenever that button, for example, is clicked, the function executes. But if you want to control that a certain snippet of code runs for every item you have in an array or runs 10 times, then you would have to put 10 function executions, for example, into your code. And loops allow you to write such code repetition in a more dynamic and flexible way. Now in JavaScript, we have 4 main loops, and that's the for loop, the for off loop, the for in loop, and the while loop. And for the while loop, we also have one variation, which I'll also show you. Now, what's the idea behind each of these loops and when do you use them? The for loop together with the while loop is the oldest loop. It's been in JavaScript forever. And the for loop allows you to execute code a certain amount of times. And you use a counter variable for that, which you typically increment or change with every loop iteration. So that means that with a for loop, you can easily define that a certain part of your code should run 10 times, 20 times, a million times. Here's an example. This is how a for loop looks like. You have the for keyword, then between parentheses you initialize or you set up that loop, and that consists of 3 parts. Begin phase, where you initialize variables you can use inside of that loop. So between these curly braces, and that's important, the variables set up there are really only available inside of the loop. Then we also have separated by a semicolon, so not by a comma, not by a colon, but a semicolon. We have a condition, an exit condition, which basically defines when we stop executing that code between the curly braces. And then we have, separated by another semicolon, the code that should run after every loop iteration. And there you could do whatever you want, but typically you just change that variable which you initialized and which you also use in your exit condition. So this loop, for example, would initialize I, and I is a name which is often chosen. It stands for iterator. So you choose I and you set it to 0 initially. Then after every loop iteration, so after this console log body ran, it's incremented by 1. And then before the next loop iteration, before every loop iteration actually, this condition I smaller 3 is checked and the loop body is only executed if that condition yields true. Which of course means that in this example here, we would print the values 0, 1, and 2, but never 3, because after the 3rd loop iteration, I gets incremented to 3. Before the next iteration, this condition checks if I is smaller than 3, which of course is not the case if I is equal to 3, and therefore it would stop executing that and move to the next line of code after that for loop. That's how a for loop works. And of course, needless to say, we'll see that in action right after this lecture. Now, another loop you have, which is a bit newer, but now also very well supported in JavaScript, and that's the for off loop. Now, that executes for every element in an array. It allows you to execute code for every element in an array. It looks like this, kind of like the first for loop, but a bit different. Between parentheses, we don't have these 3 parts. Instead, here we have the off keyword, and we create a constant. Could also be a variable, but typically you create a constant, which gives you access to one element of the array at a time, and then this body between the curly braces is executed for every element in the array. And L in this case then refers to that element in the array for this current iteration. And this is convenient for example, doing something with every element in the array or outputting it to the console or whatever you want to do. Now, for off helps you with arrays. We also have for in, and that allows you to execute code for every key in an object. This is how it looks like. And there we basically have the same syntax as in a for off loop, but with the in keyword instead of the off keyword. And an important difference is that for off is built to work with arrays, for in is built to work with objects. And there you get access to every key in the object. So that's the part on the left side of the colon when you create these key value pairs in objects. And then this second line you see here, console log, object, square brackets, key. That's actually a syntax we haven't used before. This is a way of dynamically accessing key value pairs in an object when you don't have the key name, but instead you have a variable or a constant that holds the key name. Then this gives you dynamic access to the value stored for that key in the object. And of course, we'll also see that in action in this module. Now, last but not least, we have the while loop. The idea behind the while loop is that you execute code as long as a certain condition is true, and only if that condition is somehow set to false, you exit out of the loop. It looks like this. The idea here basically is that you don't really work with a counter, though you could also do that here if you check the counter in your condition, but that you maybe have some boolean which you then change at some point of time inside of your while loop, and you continue executing code until this is done. So these are the different loops. Let's now have a look at them and see how we can integrate them into our project or generally work with them. Now, I think a great place to work with the loops is at the bottom of the app.js file, our nice little print log handler. Right now here, I print the entire array like this, which means that we get output like this, which is not super readable. With the loops, we can actually improve that because now we can loop, for example, through all entries in the battle log and output something nicer there. But I'll actually start with another loop, and that's the normal for loop. I say normal because that is the oldest for loop, and that also is a syntax you find in pretty much any other programming language. Not necessarily the case for off and for in, but for like this and the while loop, you will find that in 99% of all programming languages you can learn. So a for loop is created with the for keyword, then with parentheses, and then you have these three parts in there. The first part is a part where you initialize things for the loop. You could run a lot of different code here, basically any expression, so anything but an if statement or another loop can be executed here. You could call a function in here, but typically what you do here is you initialize a variable. You could initialize multiple variables, but in most loops you only need one, and that's that helper variable which you change after every iteration to execute code. So here I'll go with the classic example of initializing I to be 0. By the way, that should be a variable created with let because it will change in every loop iteration, so therefore it's a variable, not a constant. Then you have your exit condition, which is evaluated before every loop iteration, and there we could use that example from the slide with I smaller than 3, which means the loop body will only run if I is smaller than 3, which of course is the case initially since I is 0. And then separated by another semicolon, you have the code which you want to execute after every code execution. There you can do whatever you want. You could also omit this by just having a semicolon and nothing thereafter. Side note, you can omit every statement here, then you would create an infinite loop. You need the two semicolons here though. Now you would have a loop that runs infinitely, which is something you should be careful about because it can crash your browser since it clutters up memory and takes away all resources. But you could do that. In some rare cases you might need that. Here I don't want it, so I will stick to the old syntax, and I will also provide a third part here, and that's my code that runs after every loop iteration, and there I will increment I by 1. Again, here you could do different things. You could also say I plus 2, or I minus 3, so you don't have to increment it, but that's the most common use case, that you have a counter which you increment by 1, and you have some exit condition. You can of course also use values here which are dynamic. For example, here we could use battlelog.length. The length property is available by default on arrays, and this gives you the amount of items in the array. And this is actually a quite common way of going through all items in the array if you don't want to use the for-off loop, which is a bit shorter. But if you don't want to use it, because you have to support very old browsers, for example, but more on that in the browser support module later in the course. But then you could use this and dynamically derive the length here, and therefore go through all elements in the array by simply having a loop that runs as long as you have items in the array. So that's just a side note here. I'll hard code free, and then for now just console log, let's say a couple of dashes here, so that essentially we should print 3 lines of these dashes here when we run print log. So let's save that, go back to the browser and reload, maybe perform one action and then click show log, and indeed you see 3 lines. You don't really see 3 lines here because my browser, the browser developer tools, automatically combine similar outputs, but you see the 3 here, which means it would have printed that 3 times. It just did merge it together into one output to save some space here, but it printed that 3 times. Now you might wonder why 3 times when we only execute this code as long as I is smaller than 3. Well, keep in mind that we initialize it to be 0, then we check this, then this code runs, then we increment it to 1. So we printed this once thus far, now I is 1, still smaller than 3, so we print this again, we increment I to 2, so now we printed this 2 times. Now I is 2, still smaller than 3, so this condition gets checked and is true, so now we print this a 3rd time. Now thereafter we increment this to 3. Now for the next iteration, this gets checked at the beginning as always. I now is 3, is no longer smaller than 3, therefore we exit out of the loop, but until this point we printed this 3 times, which is why we see the 3 here. So that's the normal for loop. Now, as I said, you can configure this in a broad variety of different ways. For example, you could also have a for loop where you start with I being equal to 10, and you want to go as long as I is greater than 0, and then you decrement I for every iteration. And then maybe here we console log I. You could do that too. You have a backward counting counter now. If you do that and you click show log, we see 10, 9, 8, and so on all the way up to 1. We don't see 0 here because our exit condition is that I should be greater than 0. So for I equal to 0, this will never run. But this is also something you can do. And it really depends on which app you're writing and which use case you're having, which kind of for loop you want. This by far is the most common scenario, that you start at 0, that you increment, and that you then have a hard-coded or dynamic exit condition here. So either hard-coded like this or dynamic with something like battlelog.length. So this is also quite common to have an array length here as an exit condition. But theoretically, you can initialize I to whatever you want, have whatever condition you want to have here. Of course, also combined conditions are possible. And you can also adjust I or whatever you want to do here in whichever way you want. You also don't have to adjust I here. You could leave this empty, as I mentioned, and instead adjust I in here. That would also be possible. You could do that, for example, if you want to adjust I before you do something with it. Because normally this part here after the last semicolon runs after your code here, so after your loop body. If you want to do the adjustment before that runs, you can omit that last part and manually adjust like this. And now you will see if I reload here and I cancel and click log, now we count down from 9 to 0 instead of 10 to 1, because now we increment I before we print that. So that's all possible. You have a lot of flexibility there, and I can only encourage you to play around with that. For now, I'll leave it at that because we could spend hours just trying out different combinations here. But that being said, this is the most common scenario. And instead, let's move on to the for-off loop now. So we print that nice separator here 3 times, even though in the IDE we really only see it once, but theoretically we create it 3 times. Now let's say thereafter we really want to output something for every item in our battle log. Now as I explained, we can do that with the normal loop here, And here we can reuse I because it really only exists for that loop. So not even for the entire function, but only for that loop here. So we can reuse it in another loop. That is possible. And then here we can go all the way up to the length of our battle log array, increment I, and then here we could console log battle log, and then you learned that you can dynamically access an element in an array with that square bracket notation, and then you provide the index of the element, which is 0 based. But of course here we don't hard code the index, but instead we use I as an index, because that allows us to access the ith element for every loop iteration. So for the first iteration, where I is 0, we access the element at index 0, which is the first element. Then we increase this to 1, assuming that we have a length that is greater than 1, so more than one element. So then we have I equal to 1, so we access the element at index 1, which is the second element in the array, and so on. So now if we remove that console log statement at the bottom and I just leave this here, if we now reload again, and then we maybe attack, strong attack, attack again, and show the log, now you see the log looks different because now we're printing every element on its own. We're doing this because of that for loop where I go all the way up to the length of my battle log, and then I console log every element on its own instead of console logging the entire array as we did it before. So this is something we can do, but as you learned, there is an alternative if you want to go through all elements in an array, and that's the for off loop. There you work with a constant instead of a variable with let. You could use let, but using const is better because unlike this for loop, I will not change. Instead, you get a new constant for every loop iteration. So behind the scenes, JavaScript will create a brand new constant for every loop iteration. Not alter the previous one, but create a new one. And therefore, you can use const because it will never be altered. It will just be recreated. So basically, it's dumped after a loop iteration, and then for the next iteration, a brand new one is created, you could say. So we're also not redeclaring an existing constant, but we're really just getting a brand new one and the old one is dumped. Technically, it has something to do with the scope where this is created, but that's something we'll have a closer look at in the next course module. So for now, just keep in mind that this gets dumped after every execution and we get a new one. You can give this any name you want, just as you could use any name up there which you wanted. You don't have to use I, it's just a convention to use I. Here we could go with element or log to describe what's in the array, and we do have log entries here, so we could name this log or log entry. And then you need the off keyword, and then the name of the array which you want to go through. And this really only is available for arrays, and you can't use it on variables that hold numbers, for example. It works for strings because strings are kind of like arrays of characters. More on that later in a separate module, but it doesn't work for numbers or booleans or objects. So here we go through battle log through this array. And log entry now is a constant which, as I said, gets created for every loop iteration. So between the curly braces, we can now use that. And here again, we can output log entry, for example. And if we do that, if we output log entry like this, what happens is that if we reload this app and we attack and strong attack, we get the same output as before, unsurprisingly, because we're going through all elements in our array, get access to it in the log entry constant, which exists for the lifetime of this iteration, and then output it. So it's basically the same as we had here, but of course it's a bit shorter, and it takes advantage of this special for loop that was built specifically for going through arrays and getting access to the elements in there. Now, one important side note here, with this approach, by using the old for loop, you automatically have access to the index of every element as well, because I is just the index. With this syntax, you have access to the element, but not to the index. You don't know which index this is at. You could manually get access by defining a variable outside of the for of loop, which starts at 0 because your index starts at 0, which you then increment in every iteration. And then here, this would be your index, but you have to manage this on your own with the extra variable. The for of loop like this doesn't give you access to the index. So now here, you will see if I add some entries and I log this, now we have the index being printed after every entry, but again, we have to manage this manually if we need it. Now we saw the for loop and the for off loop. Now there also is the for in loop for going through all the key value pairs in an object. Now I also want to do this here in the print log handler, because there in the for off loop, log entry actually is an object, right? It's this here, and this is a JavaScript object. And you can have loops inside of loops, so you can have such nested loops. You can have a normal for loop in a normal for loop, you can have a normal for loop in a for off loop, you can have a for off loop in a normal for loop, so you can mix and match them as you need. You can also have if statements inside of for loops and for loops inside of if statements, and the same is true for while loops. So you can combine these structures and these concepts as you need to. That's also very important to understand. You are not limited to only using for loops or any loop on the top level of a function. You can use them outside of functions, inside of if statements, inside of else blocks of if statements, inside of other loops, and if statements inside of loops, and so on, as I said. So you can nest these structures as deep as you want. So here, for example, I want to adjust my output here, and I want to console log a little string identifier where I use the backticks to dynamically inject the value. Then I'll add a hash symbol, a hashtag, and then this $ curly brace syntax to output the index. So that's basically just giving me the number of this log entry starting at 0. And then I don't want to console log the entire entry like this, but instead go through all the entries in there, all the key value pairs in there, by adding such a for in loop. It looks a lot like a for off loop. You create a constant, because just like with the for off loop, this variable, this constant, is recreated for every iteration. And then here we get access to the key. You don't have to name that key. You can name it whatever you want. You could name it property, whatever you want to name it. I'll go with key. Then you use the in keyword, and then your object, either created in place, just as you could create an array in place here if you wanted to, or more often, you refer to some variable or constant which holds an object. So in this case, to log entry. And then you have curly braces and your loop body. Now, of course, the implication of having a nested loop like this is that this outer loop will run, and then for every iteration of that outer loop, that entire inner loop will run, and only once this is completed, the next iteration of the outer loop will kick in. So that's how these two loops will work together. Inner loop has to complete for the next outer loop to continue, and then a new inner loop is started, and so on. So now here, we can console log the key value, for example, and key here really is the name of the key. So event, final monster health, final player health, target, and value. These are the keys, and that's what is stored inside of the key constant. And if we now also want to get access to the value for that key, well, then we have to use a different syntax. Then we can also console log this, but here we need to refer to our object, so log entry, and now the dot notation won't work, because if we type dot key here, JavaScript will try to find a key, a property, named key in here. And there is no key property. We only got these 5 properties here, event and so on. So there is no key property, no property with the name key. Because key is the name of this constant, not of a property in the object. But the value of that key constant then is the name of a property of this object. So the value here in key will be event, and for the next iteration, final monster health, and thereafter, final player health, and so on. So for our object, we want to access the property with the name event and with the name final monster health, and so on. And these names are stored in key. So what we want to tell JavaScript is that it shouldn't use key as the name, but the value stored in key as a name. And we do that by using a different syntax for accessing properties, which we haven't seen before for objects, and that is that we use square brackets here. Now we don't use it as we use it on an array, where we use 0 and 1 and so on, but instead here you can enter a property name. And you could hard code it like this to access the property with the name event. So this would be similar to .event, but you can also pass in key here, and JavaScript will then extract the value stored in this constant and then access the property with that name on log entry. And therefore now in this inner loop, we will now log the name of the property and then its value. So a lot of talking. Let's have a look at that. Let's reload, strong attack and show the log. And now what you see here is a lot of output. We have this hashtag 0, which means it's the first log entry. And then we have event and its value. And then the value property and its value. And the target property and its value. And so on. And then, because I never change I as I just see, we would need to increment this. Forgot that, accidentally deleted it. So therefore we still have hashtag 0 here. That should be hashtag 1 with the updated code here. But then we have the next log entry with different values for the properties. Now, of course, that's not super readable, but of course we can change this. For example, we could add string interpolation here to output a readable string, where we then first output the key, and then maybe such an arrow here with the equal sign and a greater sign. So this is just some text, so not something JavaScript tries to parse. It will just create some text here, and then output the log entry value for that key here. And now that should be more readable if we do it like this, and we reload, and we attack, and strong attack, and show the log. Now here, if we maybe expand this a bit, with the first log entry here, then event with its value, value with its value, and so on. Second log entry with index 1, and so on. So this is how we could now output our log. If that's more readable or not, I'll leave that up to you, but it shows you how you can use the different loops here and how you can also use loops inside of loops, and how you can use a for-in loop to go through all keys in an object and still get access to the values that are stored for these keys. Now, what about the while loop? I have no great place to squeeze it in here, though I will say you can also use a while loop to replace a for loop. So if we would want to replace this, we would have to manage the variable manually. Now, since I use I down there, I now have to use a different name because now we're initializing it in the function, and there we must only use each name once. So here I'll go with j, initialize this to be 0. And then we can add a while loop with the while keyword, then a condition between parentheses, and then your loop body. Now, if you put something like true here, this is obviously always true, and therefore this would give you an infinite loop, which you want to avoid because it will crash your application. Instead, here we could check if j is smaller than 3, and then here we can console log our code from up there, so these dashes here, and then simply increment j, and now we manually replicated this behavior. Though I will say, if that's what you want, you would go for the for loop. This is just so that we can have a first look at while. So if I reload, strong attack and show the log, we see our dashes here 3 times just as before. But again, you wouldn't really use while for that. You would go with the for loops. So let me quickly comment that back in and comment out the while loop. Now, a more realistic use case of such a while loop might be that you create some dynamic value in there, and at some point of time you want to stop. Let's say you're generating random numbers, and I'm doing this here in the browser console, so I create my random numbers variable, and you have another variable finished, which initially is false. And then you write your while loop where you check for it not being finished, so with the exclamation mark, because this has to return true to make it into the body. And then you place your cursor between the curly braces, you hold shift and press enter. Now you can write multi-line code here, because pressing shift without enter executes the code. Don't do this yet, because then you'll have an infinite loop and you'll have to close your browser and reopen it to get back to work. So now we have the while loop, and in there, I now generate a random number with math random. Haven't used that before, but this gives you a random number between 0 and 1. Again, hold shift, hit enter to enter a new line here. Add it to your random numbers here. So random numbers push, random number. And now let's say we're done in another new line with shift enter. If random number is greater than 0.5, which will take maybe just 1 try or 10 tries, it's random. So if random number is greater than 0.5, then again, curly brace, hold shift, hit enter. Then in here, I want to set finished to true, which means then this condition will no longer be true, and therefore we shouldn't execute this loop anymore. At this point of time, I then also want to console log my random numbers. So if you now hit enter, this executes, and you see here, it does execute for me with 4 numbers that are generated, and this was the number greater than .5, after which it finished. If I repeat this code by pressing the up arrow here, which quickly recreates the code we just wrote, so the up arrow key on your keyboard, then hit enter. Well, now it doesn't even execute because finished, of course, was set to false, to true. So let's set finished back to false here actually. And then thereafter, by pressing the up arrow key multiple times, go back to the while loop, hit enter again. Now it took 5 tries. We have 5 elements here. Though that's not entirely correct. Of course, it used the old array and just added 1 element, so it actually took only 1 try. Let's do this again. Let's set finished to false, and let's also reset the random numbers array to be an empty array. And now repeat while. Now this took 2 tries here in my case. Of course, how many tries it takes will differ for you, but this is an example where you might use while because you don't know in advance when you will be done. You don't know how often this will need to run because the exit condition is derived inside of the loop code. Now there also is a variation of while, and that's do while. For that, I'm back in our code here, and I'll bring back this while loop with j, and there we created these 3 dashes. Now, if I log j instead, let's see what that yields. If I save that, open the console in the developer tools and reload the page, and then press show log, we see 0, 1, and 2. The same we earlier had for the for loop, which makes sense. We start at 0, check this condition, 0 is smaller than 3, so we print this, increment this, now we have 1, smaller than 3, we print this, increment this, now we have 2, smaller than 3, and for a third time we print this, the value currently is 2, which is the latest value, the most recent value we see here. We increment this, value now is 3, this is not fitting our condition anymore, so we exit by that time. So this works as expected. Now let's say you actually always want to execute your loop body before the condition is checked, because at the moment the condition is checked before the loop body is executed, maybe you want to do it the other way around. Well, then you can use a do while loop. For that you can cut your body here and then add the do keyword and add your body here. And then typically you move while right after the closing curly brace, though technically it also works if it's in a new line. What this does is, it now executes the body first, and thereafter checks the condition. If you now save that and you reload and you press show log, you see we print the same as before, because we still exit after this is equal to 3. But you'll notice a difference if you, for example, set j to 3 initially. If you do that with a do while loop, and I reload here, and show log, you still see 3 being printed here. Now if we go back to the other while loop without do, so by cutting this and removing the do keyword, if we do that here, then you will see that now actually, if I reload here and press show log, we don't see the 3 here. The reason for that is that 3 of course is not smaller than 3, and here we check the condition first, but with do while, in which case, by the way, it's also common to add a semicolon after while, not a must do, but you typically do it in this notation, not after the normal while loop, but that's just a side note. But the important thing here is here, this code runs first and thereafter this is checked, so that's why we here see 3 being printed if we initialize j to be 3, because this condition, which actually finds out that we don't want to continue for j being equal or greater than 3, is only executed after we first ran this loop body. So that's while and do while. You typically will use for loops more often. While loops are kind of niche. There are some use cases where they're really great, but for the majority of use cases, you typically work with for and for off and for in loops. That just happens to be the case, the way we write programs and what we want to do in there. But it's good to have while loop, especially if you have some condition which changes inside of the loop and you don't know in advance how often you want to execute that loop. Then while loops can really shine. So I'd say it's time to practice some of the knowledge you gained in this module. Here is an assignment. In this assignment, which has the same structure as other assignments, you find 3 files and these are your tasks. In the first task, I want you to have a look at the assignment.js file because in there you will find a variable, or a constant to be precise, which is a number between 0 and 1 randomly generated. This one here. MauthRandom is a built-in function in the end which we're using, which is available in the browser, which generates a random number between 0, which is included as a possible result, and 1, which is not included as a possible result. Now I want you to write some code that shows an alert with any message of your choice when that generated number is greater than .7. So you learned all you need for that. With control structures, you can run different code for different situations. And here I want you to run some code, some special code, showing that alert when that number is greater than 0.7. Now thereafter we'll move on to task number 2. There the goal is to create an array of numbers, any numbers of your choice and as many elements as you want, and then loop through that array in 2 different ways. Now we learned about different ways of looping, and here I want you to pick 2 different ways to go through that array and output all the numbers inside of the loop with console log in the developer tools console. Now in task number 3 thereafter, I want you to adjust one of the loops of the last task such that it actually starts at the end and then loops through the array. So it doesn't start at the first element but at the last element and then goes through the array backwards, so to say. So that's your goal here for task number 3. And then task number 4, here the task simply is to create another random number. So you can simply just copy this code here and create a new constant with a different name to store another random number. And then show an alert in 2 different scenarios. So kind of related to task number 1, but a bit different. You either should show an alert with any message of your choice if both random numbers, so this random number and the one you added, are greater than .7, or if at least one of the 2 is not greater than .2. So you got basically 2 conditions you want to check here. These are your tasks. You learned everything you need for that. Once you're done, or if you're getting stuck, of course, have a look at my solution code and video where we can then also solve this together. But definitely try it on your own first. So let's start with task number 1, where we want to show an alert when that random number is greater than .7. Now we got the random number here stored in the random number constant, so all we need to solve that task is an if statement where we check the value stored in random number, and I want to check if it's greater than 0.7. So for that we can check if it's greater than 0.7. Now here I'm just saying greater than, so that greater than operator is right. Of course you could also use greater than or equal if you also want to include 0.7 in the condition. Now, if this yields true, then we'll make it into this if block. So in that case, I'll show an alert where I say greater or equal than 0.7. Of course, you can show any text you want here. Now, as a bonus, we could also add an else case here, as you learned in this module. And, for example, say not greater, but this was clearly not part of the task, so you absolutely don't need to do that. I'm just doing it here as a little bonus. And with that, if we save that, if we reload this, well, here I get the alert, not greater, not greater, now I get greater. So that will of course differ because the number is different every time you reload this, and only sometimes it will be greater than 0.7. Since this is equally distributed, in around 30% of cases it will be greater than 0.7 to be precise. Now that's task number 1 solved. Let's move on to task number 2. Now for that we need to create an array of numbers and then loop through that array in 2 different ways. So here I have my numbers array. You can of course name that constant or variable however you want. And here, to keep it simple, I'll just have incrementing numbers in there. But of course you can store any kind of numbers in there. You can store negative numbers, floating point numbers, whatever you want. Now to loop through that, I will actually show you 3 different ways, but only 2 are required per the assignment, of course. Way number 1 is to use a for loop, where you then create a variable which exists inside of that for loop, typically named I, but the name is up to you, where we start with a value of 0 assigned to I. We loop as long as I is smaller than the length of numbers. The length property exists on arrays, and it tells you how many items are in that array. And then we increment I on every iteration. Now inside of this array, I can then console log numbers for the given index I. That's what we can do here. Now that's the first way of looping. Second way is to use a for-off loop, where we create a constant. By the way, here it has to be a variable because this is going to change inside of the loop. Here a new constant is created for every iteration, so here we can use a constant instead. And I'll name this num of numbers, and this now also gives us access to all the numbers, so here we can console log num. And now the last way is to basically manually recreate that for loop by creating a counter or whatever you want to name it variable, and then have a while loop where we check if counter is smaller than numbers.length. And if it is smaller, we'll make it in there. And then I want to console log numbers for the given counter, and thereafter increment the counter. So it's basically a rebuilt for loop as we have it up there. If we now save that and we open the developer tools here, go to the console, and we reload, we see the alert, and then we see a couple of loops. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the free loops from lines 12, 16, and 21, 12, 16, and 21 are working. With that, we solved the second task. Let's move on to task number 3. Here, we should adjust one of the loops such that we actually go through the array backwards, so starting at the end. With for-off, that's not really possible. We would have to change the array for that. And there are methods to reverse an array, for example, to sort it. And you will learn more about that in the arrays and iterables module. For the moment, we don't really know how that works. Instead, we can either use this or the while loop approach. And here, I'll go for the for loop backwards approach. So for that, we can basically copy this for loop from up there, but we don't start with I set equal to 0, but instead we want to assign the index of the last array element as a starting value to I. So that is numbers.length minus 1. The minus 1 is important because you have to keep in mind that indexes in arrays start at 0. So the first element in an array has an index of 0. The last index, therefore, has an index of array length minus 1. So now this is our starting condition. We want to loop as long as I is greater or equal than 0. We need to check for equality because we want to include 0 as a value for I. And then we want to decrement I by 1 once we're done. And with that, if we save this and we then reload, if we scroll to the bottom of the console log, we should see 654321 stemming from the output in line 28, which of course is this output. So this is now task number 3 solved. Now let's move on to task number 4. There, I want to create another random number and then show an alert in 2 different scenarios. So let me copy this code here to create a random number. This constant will of course also be available down there, but now I have random number 2 as well, which is another random number. And now we want to show an alert if both are greater than .7 or at least one of them is not greater than .2. So we can check if random number is greater than .7, but now we also need to tell JavaScript that this alone is not enough, but that random number 2 also needs to be greater than .7. And for this we can use the logical AND operator, 2 ampersand symbols. And then we say and random number 2 has also be greater than .7. Now only if both yield true, this overall expression yields true. And therefore only if both yields true, we'll make it in there. So then I will show an alert where I say greater than .7. Now that's not all, however. We also should make it in there if at least one of the two is not greater than 0.2. So actually our complete condition is either this part here is true or another condition. So let's wrap this here into parentheses to make sure that this is evaluated on its own. And then we can add a OR symbol here, logical OR, two pipe symbols, and have our other condition. Now, by the way, theoretically, you don't need the parentheses here because AND has higher precedence than OR. So actually, these two here are evaluated first, no matter if you put it into brackets or not. But I like to add brackets to make it really clear. But then thereafter, the part after the OR condition is considered in conjunction with this first expression. So we want to make it in here if the first part is true, or if at least one of the two is 0.2 or smaller, or is not greater than 0.2. So here I then want to check if random number is smaller or equal than 0.2, or random number 2 is smaller or equal than .2. And now I reformatted the code with my IDE shortcut. Now we actually have a setup here where we ensure that either this is true, or this, or this. And in all these cases, we make it into this block here. So here I then say greater than 0.7 or smaller than 0.2. Now to validate that this works correctly, I will also console log random number and random number 2 here so that we see the concrete values and then see if the result, so whether we see the alert or not, makes sense. So let's now save that and reload. And now I get greater than 0.7 or smaller than 0.2. And indeed we see one number is greater than 0.7, but that alone would not be enough because they both have to be greater. But we see this alert because the other number is actually smaller than 0.2, and indeed it is enough. If just one of the two is smaller than 0.2, we'll make it in here. So this makes sense. Let's reload this. Now I didn't get an alert for this second check, and that makes sense because both are smaller than 0.7, so they're not both greater than 0.7, and none of the two is smaller than 0.2. Let's reload one more time. Still no alert, makes sense. One of the two is greater than 0.7, but the other is not, and none of the two is smaller than 0.2. Reload again. Now I got the alert again because one of the two is smaller than 0.2. Here I also got the alert because one of the two is smaller than 0.2. And now here I also got the alert because both are greater than 0.7. So this seems to work, and with that, we overall solved this assignment. Now, to conclude that part about loops, I want to dive into two important keywords which can help you control your loop execution. And that's the break and the continue keyword. We saw the break keyword already in our switch statement. There we have break to avoid that fall through mechanism. We can also use break inside of loops to leave the loop execution, to stop the loop execution earlier than it normally would, so to kind of cancel the loop execution. How does that work? Now let's say we only want to output one log entry. Well, of course there are various ways of achieving this, but one way would be to simply add a break keyword here. Maybe after this I++ thing. Doesn't really matter for this example though. Now what this will do is it will tell JavaScript, and it works in any loop, by the way, not just in for-off loops, but in all loops I showed you. It tells JavaScript, stop this loop execution of the loop I'm calling this in. So if you're calling this in a nested loop, it will stop that nested loop execution, but continue with the outside one, which of course means that for the next iteration of the outside one, a new inside one is started, and that will then run. But the currently running inside nested loop will stop when you call break. If you call break in the outside loop, well then this outside loop is finished, and therefore there also will be no next run of the inside loop because that only runs for every iteration of the outside loop. And since we break out of that and we finish that outside loop, there's no more inner loop execution too. So break stops the loop in which you call it. So in which you call it directly. So you have to not have it in a nested loop, but directly in that loop as we do it here. This break call here will stop this outer for-off loop. The result of that is that if we save that and we go back to our program, and I then attack and have a strong attack, and I then click show log, we only see one entry here. we see our attack. We don't see the attack by the monster. We don't see our strong attack or the response on that by the monster. We only see that very first event we wrote to the log, so that very first attack we launched. That's how break works. Now we could actually use that to make sure that whenever we press the show log button, we only output one event at a time, but of course not always the same one. That would be great. And for that, we can add a new global variable where we keep track of the last event we logged. So for that, I'll add a new variable up there, last logged event or last logged entry. And initially that's not even 0, that's -1 or just not defined, let's say. And then we can use the last logged entry down there in our loop where we log the entries to set last logged entry equal to I. So in this case to 0. Now we can add an if statement here and say if last logged entry is not set, so add an exclamation mark here. So if this is undefined or falsy at the beginning, which it is, or if last logged entry is set and it's equal to I, then I want to log my event. So we move that code into this if statement. And then, since we now logged something, we update the last logged entry to that I number. And thereafter, we increment I, and we break. This is still not the finished logic. Now, if I save that, and I go back to the web page, and I attack and strong attack, and I click show log, we see that entry. And if I click show log again, we see that same entry still. So we can add that same entry multiple times. So we haven't changed a lot here. The reason for that is that we set last logged entry here to I, so to 0 for the first run. And here we check if we have no last logged entry or if last logged entry is equal to I. But we always start at I0, so this is always true. And therefore we always log this. Now the trick is actually to change this here to look for last logged entry to be smaller than I. And if we do that and we go back to the page, I can click attack and strong attack and then show log, and we have one entry. But if I click it again, we still keep on printing results. The reason for that is that this change here will actually yield true if last logged entry is undefined, but also if it's 0, because as you learned, 0 is a falsy value. It's treated as false. So this here, with the exclamation mark, actually yields true and therefore executes this code if last logged entry is 0. So I'll combine this first condition here with another condition that last logged entry is not equal to 0. So if this is falsy, but it's also not falsy because it's equal to 0, or last logged entry simply is smaller than I, then we want to log something. So now with that, if we go back to the web page, and we attack and strong attack, and I click show log, we have an entry here. But if I click show log again, now you see I only print my stripes here, my dashes, but I don't print any real log entries anymore. And the reason for that is that we don't make it into the if block anymore. And that makes sense, because I always starts at 0 when print log handler is executed, which is the case for every click. So that's not incremented across clicks. For every click, it restarts at 0. Last logged entry, however, does change with every click. It starts uninitialized, and then after the first log being printed, it is set to I, which is 0. So it's 0 after the first click. And thereafter, this code never runs again due to the logic we wrote here. So now the next step is to move break into this if statement so that the loop actually continues and has a chance of reaching a new I. So now if we save that, and we reload, and then we attack and strong attack, and now we click show log, we have that first event, player attack, with index 0. If I click show log again, with index 1, which is the monster attack. And now if I clear that, we can still continue pressing this button. Now we have some logic that allows us to log event by event with every new click until we have no more events, which is when we only print our dashes. Now, of course, you could add another if check here to make sure you don't execute any logic in here if we have a last logged entry that is greater than the length of our battle log in the end, which means we have no more entries. You could do that. So that's the break keyword. It allows us to break out of a function execution, for example, to do something like this, but you can do it for whatever reason you have in your code. It allows you to break out of a loop execution earlier than it normally would finish, so before the loop really finished. In this case, whenever we printed something to the console. But of course, you can use break for whatever reason you have. Doesn't have to be because you only want to log one thing at a time to a console. Could be any reason why you want to stop a loop iteration before it really is done. So that's break. Now I mentioned we also have another keyword, and that's the continue keyword. The continue keyword is a bit like break. It also stops the current execution of this code in your loop, but it doesn't stop the entire loop. So instead, it just moves on to the next iteration. I can best show how it works here in the console. If we add a quick for loop here, a normal for loop with I equal to 0, I smaller than 5, and I++, let's say, curly braces, and then shift enter to write some code between. And now, of course, if I console log I here, unsurprisingly, we print 0 to 4. Now press the up arrow to be able to edit this again. And now let's add a little if check in there where we check if I is equal to, let's say, 3, which is one of the values we're printing here. If that's the case, for whatever reason, I don't want to print it here. Well, then, of course, we could use break, right? This will stop the loop execution. If we hit enter, now we see 0, 1, 2, but we don't see 3, but also not 4, because we canceled function execution with break. This might or might not be what you want, because I actually only wanted to skip this 3 value. I didn't want to cancel the entire loop execution. And that's exactly what continue does. If you use continue instead of break, you just skip this loop iteration, so all the code after continue will not be executed, but for the next iteration it will continue as normal, so it will not break out of the loop, it just continues to the next execution. So if I now hit enter here, we see 0, 1, 2, 4, we don't see 3 because there we continue, and as I said, this means this code is skipped for this loop iteration. Subsequent iterations, like the one for 4, are executed. So break and continue give you some extra control over your loop execution. You definitely don't need them in every loop you write, but sometimes you have some code where you want to break out of a loop upon some condition being met, or you want to skip an iteration based on some condition, and then break and continue are your friends. Now there's one last feature related to break and continue, which I will be honest, you will very, very, very rarely need or use, but I still want to show it to you because it's part of JavaScript and you should learn it in this course, of course. And that's the so-called labeled statement. So let's say in this while loop, but again, this works in any loop, we have a nested loop. So we're logging j here, and then I have a for loop in there where I initialize, let's say, k to be 0. We could theoretically use I in here and it would create a new I detached from this I for this loop, but to avoid naming confusion, I'll use k in here. And k is maybe smaller than 5, that's our exit condition, and we increment k, and then I console log k here. So far that's nothing too fancy. We have a loop in a loop. If we now save that and we reload and we press log, maybe without doing anything before, we print 0, 1, 2, 3, 4. That's our nested loop in this outer loop. Now one tiny change, I'll set j to 0 here so that we run this outer loop more than once as well. So let me save that, reload, click show log. And now we have a lot of output here, and we get that 0 here. maybe to make it clearer what's coming from where, we can add outer as an identifier here, and here inner. So I'll console log two things, an identifier and then the actual value, so that we can see which value is coming from where. And now we see we have the outer 0, then this inner loop completes, then the outer loop moves on to the next iteration, its second iteration, therefore we have a 1 there. We have a new inner loop starting at 0 again, all the way up to 4, a new outer loop iteration, a new inner loop, and so on. Now let's say you have some code, and typically of course you would not just be working with some numbers here, but you have some application, some other logic, where you have some condition in your inner loop that should actually finish the outer loop. So for example here we could say if k is equal to 3, then that is a reason for us to stop the entire loop execution. Now, of course, we can do that with break, but what will actually happen here is that we just stop the inner loop, because as I mentioned, break will stop the nearest loop, so to say, the loop to which it belongs. So if I now reload here and we execute this code with show log, you see outer actually continues to work. We have outer 0, outer 1, and outer 2. And just the inner loop always stops after 2 because we break after a value of 3, or when k reaches a value of 3. Now what if we want to break the outer loop though? Well, you can do that with a so-called labeled statement. And that's really something, as I said, which you will rarely see and use in JavaScript. You can assign a name to this loop, and that again works on any loop. Actually, not just loops, you can assign it to any expression, but it really only makes sense on loops. You could name this outer while, so any name of your choice, and then you add a colon and then a white space. And now this is a name for the loop in front of which you added this. And you can add this, as I said, in front of any expression, but you typically do it in front of loops, because there you can use that because that is meant to be used with break and continue. You can also, but you don't have to, add this here in front of that 4 and maybe name it inner 4. And now here you can use break like this to finish the inner loop, but if you want to finish the outer loop, now you can say break and then pass the name of the label you assigned to your outer loop. So in this case, outer while. And now this allows you to break a different loop than you're currently in. So now if we do that here, and I click show log, you see outer now actually finishes when inner reaches a value of 3, and we have no other outer logs. And you can do this not just from inside loops, but from anywhere in your code. So if you have an infinite loop running in one part of your code, and then you have another part in your code where you kind of react to a button click and that should stop that infinite loop, well, then you could also work with labeled statements and call break in one part of your code in your event listener to stop another loop where you assigned a label like this. So these are labeled statements and how you can use them. And you can not just use it with break, but if I comment this out, you can also use it with continue. Works in exactly the same way, just with the continue functionality, where we don't stop the loop, but only the current execution. And therefore here, in this case, we just continue with our outer loop. Though now I actually created an infinite loop here. So you will need to close that browser window here in this place. And I did create an infinite loop here because by continuing with the outer while, well, we never reach this J++ code here, right? We execute this outer loop, then we start with this inner loop right away. There, whenever we reach K, which we always will at some point of time, we continue with the outer loop. And therefore, this J++ part, which is important for our exit condition, will never run. So this actually is dangerous because we create an infinite loop here, as you just saw. So you should always watch out what you're doing with continue if you accidentally maybe create an infinite loop, which you probably don't want to do. So that's one thing. The key thing here are the labeled statements, though. The labels you assign here to your loops, which you can then use with break and continue. Again, nice to know, nice to understand if you encounter it in some examples or in an interview, but really a feature which you will rarely need as you will see as you work with JavaScript. This is something that comes with experience, but there you will see that you really don't have a lot of occasions where you would need this. Still, since it's a part of the language, I didn't want to hide it from you. Now, after all these if statements and all these loops, I want to conclude this module by diving into error handling, another form of control structure you'll need in your JavaScript code to build code that runs under different and also under harder circumstances. Now, what do I mean by that? In the JavaScript applications, in the programs you're going to write, you can't always avoid all errors. Some errors can't be avoided. And with that, I of course mean errors that are beyond your control as a developer. So I'm not talking about bugs which you introduced into your code or about syntax errors. You should have a look at the debugging module in this course to learn how you can fix and avoid such errors. I am talking about errors which you can't rule out when you're writing your code. For example, user input errors, that a user enters text like hi in a field where you expect a number. Or network errors, that you're maybe communicating with some server, something we haven't done yet but which we'll do later down in the course, and that server is offline. Or something like that. So basically things where you have no chance of ruling out that this problem occurs because you can't control what a user types into the input field. You can do your best to kind of restrict the options the user has, but ultimately users might always find a way of breaking your code, so to say. And the same for network errors. You can't rule out that a server might be offline when you're trying to talk to it. So the best you can do in these cases is that you throw your own errors and catch errors to fail gracefully, which means maybe at least show the user a nice error message, or in the best possible case, maybe you can write some fallback code so that you can recover and you don't even need to show an error message to the user. And you can do that with try catch, another control structure which JavaScript exposes to you that allows you to try a certain code which might fail, and then catch potential errors thrown in that code to then do something with them, or to do something in the case that such an error occurred. Now back in our little project, the Monster Killer project, let's simulate such a problem. We do get some user input here actually. We get that entered value, and I already do some validation here. We check whether what the user entered can be used as a maximum life. So if it's bigger than 0 and if it is a number to begin with after converting it to a number. Now, the kind of sad thing here, in quotes, because it's actually good, of course, is that parseInt doesn't throw an error if the user enters something invalid. In other programming languages, that could be the case, but JavaScript is really forgiving here, and if you enter something that can't be converted to an integer or to a number here, well, then you don't get an error, you don't get a system error that crashes your script, but instead parseInt generates this NaN value, which we check for with isNaN. So this doesn't really produce an error, but here to continue and show you try catch, I want to have a real error. And the good thing is we can create and throw our own errors. And whilst it might sound strange that you want to do that in your code, you have to keep in mind that with JavaScript you can write very big applications spanning across multiple files, and indeed you might want to throw an error in some parts of your application so that you can use these official error management tools to handle that error instead of having to write a bunch of if statements in a couple of different places of your code. So especially in bigger applications, it's quite common that you throw your own errors in some parts of it. And here we will throw our own error so that we can practice with try catch. In other situations, which we'll see later in the course, for example, when communicating to a server, you will automatically get an error. So JavaScript or the browser will automatically throw an error if things go wrong. Here for this user input, this kind of unfortunately isn't the case, so we'll do it on our own. So how can we do it on our own? Well, let's first of all move this logic here where we get that entered value into a function. So I'll cut that, and then maybe here add a new function, which I'll name get max life values. And in here, I get that entered value, and I try to parse it as an integer. And then here, I'll take that if check and put it in here to validate what the user entered. But then here, I'll not set chosen max life to 100 if this is not valid. Instead, I will change this to be a constant, which I'll name parsed value, something like this. We'll need that in a second. And then outside of that function here, I will add that chosen max life variable, which I'll for now set equal to get max life values. So I will call the function here, and in that function, I want to return the parsed value here in the end. That's the idea. But in this if statement, if we have an invalid value, then I will not return 100 as a fallback value, which we of course could do. But in order to see how you handle errors, I will use another keyword in JavaScript, which is the throw keyword, which throws a new error. And an error can be anything. You can throw a number as an error, a string, or an object. And here I'll throw an object with a message property. That's kind of the convention. Most errors are objects that have a message property, where I say invalid user input, not a number, something like that. So now we throw our own error here. And the result of that is that if we go back to our application and we open the developer tools here and I reload and I enter a valid value, then I got a different error, cannot access chosen max life before initialization. Yes, because here, of course, I should, in my if condition here, I should check parsed value, not chosen max life. Since I changed it here, we should change it here as well. So that was not what I wanted to show you. Let's reload. If I enter 100 instead, this works as before. But if we now reload and I enter a high there, which can't be converted to a number, we now get our own custom error thrown here. You see, this is just an error with which is our object in the end with that message. But it's marked as red because this indeed is now really an error, and it stops our script execution therefore. So pressing these buttons doesn't do anything. So we crashed our script. Again, you might want to do that on your own in more complex scripts so that you can use the error handling mechanism in different parts of it. Here, I'm mostly doing it so that we can now practice with try catch, because you will later also work with other things like network requests, where JavaScript itself will throw errors, and therefore you need to be prepared to handle such errors. So, how do we use try catch? The idea is that you wrap try catch around the code that might fail. So you might think, great, I'm going to put my entire program into the try block, right? We put all that code here, all of that, we move that into try, because then we catch any error that might occur. And even though we don't know yet what we can do then, this sounds good. We catch any error and we'll probably be able to do something great and have our script not fail. This is not what you should do. Don't wrap your entire script into try. It's not good for performance, and it's also a very bad programming style. You want to write code that doesn't yield errors, and you can use the debugging section to find and fix logical and syntax errors. You only want to move code into try where you can't control whether it throws an error or not. As it's the case here, we can't control whether the user enters something valid or not. So in the end, we move this line in here, but since I want to be able to use chosen life thereafter, I will actually create and declare the variable before the try block like this, and then only assign a new value to it inside of the try block. So now we have that try block which tries that code, but just like that, it's not valid, it's not helpful, and it's also not valid syntax. You also need to add a catch block. So you add the catch keyword, and then you add parentheses, and in there, a parameter, which you can give any name you want. Typically, you name it error. This now is like a function, so you add curly braces thereafter, and inside of these curly braces, this error, which was caught, is available. So this is called like a function by JavaScript, and error is the error which was thrown. In this case, it's your own error object. If it's some system error, like with the network request I already mentioned, then it will be that error object which JavaScript created for you. So here, for example, we can now console log that error to have a look at it, to see what's inside. And we could now say, okay, chosen max life in this case is 100. That's our fallback logic. If this fails, and if it succeeds, by the way, of course, this will not execute. But if this fails, if we get an error here, then this will not execute successfully, but this here will. And therefore here we can now set a value with which the rest of our code works. This is not always possible. Sometimes the best you can do is show an error message to the user. For example, if a server is offline and you can't save data on a server, there's little else you can do. You can just tell the user about that and tell him to not leave the page and try again later. In other cases like this, you might be able to use a fallback value and fall back without the user even noticing. You could, of course, also tell the user that you entered something wrong. Default value of 100 was used, so that you fall back, but you let the user know about that. That's totally up to you. So now with that, if we save that and we reload, now if I enter hi there, I get that you entered something wrong. I get that console log, which, please note, now is not an error anymore. We don't have that red background, so this is not a system error anymore. Instead, it's just a normal log message. And our app works just as before with that value of 100 being used. So that now all works, and we can play with this game just as before, but now with our own error handling logic. In this case, with a graceful fallback. In other cases, showing an error message might be the best you can do. Now, just to make this really clear again, of course the logic we had before, where we had just this if check and then also assigned a default value of 100, wasn't bad. I wanted to show you try catch, which here isn't bad, and in other cases is absolutely necessary, because in other cases you get an error if you want it or not, and you need to be able to handle it. That's why it's a good time to already practice with it here, even though in this exact case, since parseInt doesn't throw an error, you could have absolutely kept the old logic and avoided this try catch block. Now, I'm not entirely done with try catch. You can also add another element to try catch, and that's finally. Now, you add finally like this. You add the finally keyword after try or after try catch. You don't need to have catch. You can just have finally here. You need to have try though. Try catch without try doesn't exist. But you can also have try catch finally. And the idea is that the code inside of finally will now always execute no matter if you had an error or not. Now you might wonder what the idea behind that is, because the code after try catch, so all the other code, also executes here no matter if we had an error or not. So why would this be helpful? Well, you can use finally to do any cleanup work if you, for example, have a case where another error happens inside your try catch block. And be that only because you maybe throw the error again. That's also something you will sometimes do the more advanced you become. This is called rethrowing an error, and we might do some error handling here, typically not some fallback as we're doing it here though, but we might just be sending that error to our own analytics server, for example, so that we are notified of that error we had in our application. Maybe we can't fall back as we can here, but maybe we can just show the user an error message, and we also want to log the error to our own analytics servers. So we might be sending that request to our own servers here, and then we rethrow that error. We rethrow that error here so that in some other part of our code, we can then handle it and show that error message to the user. Again, that's a little hard to imagine here. I'm aware of that because this is some basic project, some basic program, but you could have multiple try-catch blocks in different places of your app. And here you only have the first one, which sends it to your own servers, and then you throw that error again. Now, in that case, still maybe you want to do some cleanup work here. Maybe release some data which you saved, maybe clear some variables. Do something like this, and then you could do that in finally. Now, I will be honest, in a lot of scenarios, you will not need finally. Especially in this example, you definitely don't need it because we can perfectly fall back. So the code after this will execute. There's no reason to rethrow the error. If you would rethrow, the code thereafter doesn't execute and only finally will. That's the difference then. That's the advantage of finally. It executes even if you do throw an error here. The other code will not because your script will crash if you then don't handle it somewhere else. But here we don't really need that because we have a perfect fallback. It's good to know that finally is there though in cases where you will have an error in catch, you rethrow or you get another error and therefore you know the rest of your script will not be able to continue. Well, then finally can be used for some cleanup work and that can be helpful at times. Now, just as with the other constructs shown here, we'll also see try catch in action again later in the course, and especially when we work with network requests, it will make more sense because then we really need it. Then there are things we can't do without it. But since it is a control structure, now is the time to introduce it. Keep it in mind, keep its general functionality in mind, that you try code and then you can react upon an error and fall back or show an error message, and you'll get more and more practice with it throughout this course. So that was a really long module, a long course section, because control structures are such a key feature in any programming language, and therefore, of course, also in JavaScript. You learned a lot about if and else if, about these logical operators, equal, triple equal, smaller than, smaller or equal, greater than, and so on. You learned how to combine conditions with and also with or, of course, which we had here, for example. You also learned about the special behaviors of and or, which you can use to assign default values or to assign certain values if some other condition is true. You learned about booleans, true and false, and also about falsy and truthy values, and that JavaScript, if no logical operator is given, tries to coerce a value that is not a boolean to a boolean value. And you learned about some of the rules, like 0 being treated as false, any other number, including negative numbers, being treated as true, and so on. That's also important, of course. You learned about the ternary expression, which allows you to write inline if statements, so to say, which you can't do with normal if statements. But if you just need a value and you have a relatively short condition and a relatively short code to get that value, then this can be an alternative to writing a more verbose if statement where you assign values to variables. And you also learned a lot about loops, about the different loops that exist in JavaScript, how they generally work, how you work with them, how you configure them. And there, of course, you also should play around with these to get a feeling for how they behave, how you can configure them, and how you can use them. And it's needless to say that throughout this course, we will heavily work with if and with loops, of course. These are core constructs of any programming language and therefore also of JavaScript. We also had a look at error handling in this module, another crucial concept which will be important in more complex programs you're going to write, which will also be important later down in the course, and which also is a control structure because it allows you to control code that might fail and then act upon an error and do some fallback logic, show an error message to the user, things like that. And besides this little project we worked on, where I can only encourage you to dive into the code, tweak certain things, and fully understand how it works and what we did there, besides that, I do encourage you to play around with these things on your own. Also, of course, use the resources you find in this module, like the attached slides. And if this is very much right now, which it certainly is, don't feel overwhelmed. These are core constructs and therefore we will use them throughout the entire rest of the course. So if you're not entirely sure yet when you would use which loop, you will get a lot of practice just by continuing with the course, of course. Because we will use loops there, we will use if statements there, we will use many logical operators there, and therefore all these concepts here will come to life over and over again throughout this course.